Hello, welcome back. Today we're going to be looking at Module 2, exploring research strategies, basically the aspects of psychology that make this a science rather than just some random thoughts or things like that. Um, we're also going to be exploring some of the things that can get in the way of good research. And so looking at some things like hindsight bias and overconfidence and some of the issues that we as humans have a tendency of using or putting into play even when it's not actually or shouldn't be a thing. Okay. Quick reminder before we get going, just as always, I'm going to be doing 4 random facts throughout the course of this lecture so for the quiz. So just be aware of that, be paying attention to it. I'll make it super obvious, again, just like always, but just make sure that you're listening for those, because those will be the parts that will get you your attendance for this lecture, for that quiz. Okay, so let's get started. So again, we're looking at Module 2, how psychologists ask and answer questions. Oh, another quick note. Again, just as always, the PowerPoint is available in D2L. You can access it the 3 different ways I recommended in the first one, or any other way you can figure out. But if you'd like to follow along, that's the way you can do it. All right. So we are on slide 2, the need for psychological science and some roadblocks to our critical thinking. So some of the big ones that are going to be in here that are going to kind of affect us are going to be things like hindsight bias, the "I knew it all along" phenomena. I love the book. Actually, the book gave a really good example of this one, where a few years back they did research and they brought in a bunch of participants and they asked one group of people. They gave them the line, "Absence makes the heart grow fonder." Okay, and they said they found that this is true. Why do you think this is? And they gave all these people gave a large number of arguments for this is why, this is what happens and all these things. Okay, another group of people they brought in, and they gave them the statement, basically just distance, like it does the opposite. Okay, and actually the absence makes the heart grow fonder is actually false. Okay, what they found is with time, essentially, the romantic feelings fade. So the more time you spend apart from each other, the more those romantic feelings fade. And they asked another group of people that same question, but about on that side, the flip flop of it, and they gave the reasoning. Okay, both groups of people thought that they were giving rational reasoning, rational arguments for why that statement was true. Only one group of people actually had a true statement to work from, though. Okay, but they thought they knew how it worked. This tendency, and then when they were afterwards, when they were like told that they were actually the statement is wrong, absence does not make the heart grow fonder, they were basically most of them were like, oh, I figured, it didn't seem like that actually would be true, but they had just given a whole series of like reasons why that statement was true. Okay, it's something we have to be aware of in ourselves. This is something that all people have a tendency to do. It's just part of our nature. Okay, so recognizing this, we have a tendency of looking back and being like, oh sheesh, like they shouldn't have done this. If I would have been in that thing, and I wouldn't have done that. Kind of a situation, whether it be looking at historical wars or battlefield decisions. You're like, man, that was a stupid move. Why would they do that? Well, in that moment, it seemed like a good move. It wasn't until you're looking back that you realize that it was a terrible move. Okay, sports, you see this all the time, right? Coach makes a stupid play, but the play works, and everyone's like, "Oh, that was genius!" I would have probably done exactly the same thing. But if that same play would have failed, they'd be like, "Oh, what an idiot! You shouldn't have done that." So that kind of tendency, that's that hindsight bias, right? You're gonna see this a lot of times with people who are watching things like, "Man, that's dumb. You shouldn't have done that. You should have done da 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 da." Well, you weren't there in that moment, so you don't know. Okay. Can be useful, right? That kind of thinking, like looking at something and going, well, this is where they went wrong. That can be useful as far as for planning for the next set of moves. But it's still the fact, if you think that you knew it, then it's wrong. Okay. Overconfidence, the tendency to think we know more than we do. There's an interesting phenomena amongst people that basically the less you know, the more you oftentimes think you know. What I have found, so I mentioned in my introduction video, I was a backcountry guide for a number of years through college to help pay for college. But what I found, like especially with rock climbing, the people who were the most dangerous were the people who had already gone a couple times. I actually did some backcountry skiing and stuff, and I also found people that thought they knew were the most challenging to work with, because they were actually potentially going to cause themselves serious injury and or others in the group. And there's that fine line, right? And I recognize this myself. Looking back, I can see this in myself when I was first learning how to rock climb. I've gone several times, and I was like, yeah, I really know what I'm doing. And then I learned more, and I realized how much I don't know, right? So that sometimes what you'll find is like the experts, somebody who really knows what they're doing, who really actually knows the information, will have a tendency of being like, I don't really know that much, okay? Because you realize that once you've mastered it to some extent, you realize the potential size of whether that be information, whether that be the skill or the craft that it's going to take. You realize what the potentials are and how far you are from that potential, which then can basically reduce that tendency toward overconfidence. Okay, but there's that sweet spot or unsweet spot, I guess, where people have a tendency of they think they know everything. Right? It's like the 6-year-old who well, I've done this before. I know what I'm doing. You're 6. You don't really have a clue, but that's part of our human nature. Okay. Perceiving patterns in random events. Random sequence is unsettling. Making sense creates calm. We as creatures do not like chaos. Okay, so we're looking for rhythms. We're looking for patterns. A lot of nature has rhythms, has patterns, right? You have the 4 seasons. You have certain signs, or certain sounds. If you hear like certain bird calls, you know that a storm might be coming later that afternoon, and all these kinds of things, right? We're looking for rhythm. We're looking for patterns. It's what it has made us survive for all of these years as a whole species. It's unsettling to think that there might be, in fact, no rhythm or rhyme or reason to a given thing, right? So if I roll dice, okay, and I roll or I flip a coin. We'll do a coin. That'll be easier. I flip a coin, and it lands on heads. I flip a coin, it lands on tails. I flip a coin, it lands on heads. I flip a coin, it lands on tails. I flip a coin, it lands on heads. I flip a coin. What will it land on next? If you said tails, you have a 50% chance of being correct, just as you would the very first time I flipped the coin. Okay. Just because it had set a pattern doesn't mean that it actually is a pattern, but our brain wants to see a pattern where there may not be one. Okay. It's a little bit of chaos. But our natural inclination, if it goes heads, tails, we assume it's going to go tails. Okay. If you ever listen to some different kind of the little edgier jazz, I guess you could say, and stuff, where they're hitting the wrong notes intentionally, it can be unsettling. Okay. And that sense of unsettling is because it doesn't follow what it feels like. It doesn't follow the pattern that it feels like it should. That's an example of that perceiving patterns. Okay. When we hear a scale, we assume that scale is going to keep going along that same line. But if all of a sudden there's a random note where there shouldn't be one, it makes your brain kind of, okay, that's what this is. Kind of like going, do, 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 and you stop. You're like, if you're a musician at all, your brain is filling in that, But if I went do, 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 boo, okay, you broke the rhythm, you broke the pattern. It's not comfortable. So scientific inquiry can help us sift through reality from overestimated intuition and illusion. So these are going to be things that are just kind of riding in the background. Okay, hindsight bias, overconfidence, perceiving patterns. These are all things that are kind of in our subconscious, right? It's feeding our conscious thoughts. So you might not even realize that you're making these assumptions, but they are there. Okay. So yeah, that's pretty much it. Next slide. Slide 3. Psychological science is in a post-truth world. So I'm not going to dig too much into the post-truth side of things. That's a very philosophical and historical thing. Postmodernism, though, essentially is what we're kind of, to some extent, at. It's kind of a fight between modernistic thinking and postmodernistic thinking. Again, if you really want to get into that, take a philosophy class. But there's this huge debate over what is truth, and is there such a thing? Okay, so this idea of a post-truth world is kind of where we are today. So why are we so vulnerable to believing untruths? Is going to be the question. Why does things like fake news fake us out, right? You hear it and you're like, oh, that seems logical. Okay. Intentionally providing misinformation. If I tell you something with the intent of misleading you, that is true fake news. Okay. Repetition. Repeated statements become more believable, right? Repeated statements become more believable. Basically, if you keep hearing the same things over and over again, especially from different sources, you're going to assume that they are true. Okay. So you hear, Joe Schmo down the road tells you something, you're like, that seems weird. But then you hear something else, like on a video maybe of a guy that you actually have some trust in, and you're like, oh, well, maybe there is some validity to this. Okay. It might be 100% false. They might have heard it from the same stupid source or something like that. But because you've heard it from different sources multiple times, you assume that it's going to be true. Okay. One random odd fact, there's room for doubt. Hear it from two sources though? Yeah, well, maybe that's a little bit more on the truer side. Okay. So this is something to be aware of for yourself when you're hearing new information, especially in today's social media world where there's just a ridiculous amount of everybody's personal opinions and things, and they're putting it forward as if it is truth. It's not. Okay. Personal opinion does not equal reality necessarily. Okay. So, availability of powerful examples, vivid images, and stories gain more attention. This is an old way, right? If I want you to remember something, I'm going to connect it to a story. If I want you to buy something, I'm going to connect it to a story. Oftentimes, advertising, marketing skills are basically connected to storytelling, right? If I can make an emotional example of this, and I can connect it to that emotion, that will stick with you much longer, right? There was a Master Lock commercial a while back, and it showed this little girl. She's riding her bike, and she's like, oh, having fun. She gets off her bike, and she goes into the house, and some guy comes along and steals her bike. She comes out, and she's just like heartbroken that her bike is gone. Okay, and it says if she would have had a Master Lock, this wouldn't have happened to this poor girl. Okay, well, not necessarily a Master Lock. If she would have locked her bike up, yeah, it wouldn't have happened more than likely, right? If you've ever done any kind of like lock picking or things like that, Master Locks are not that hard to pick. But so it's not necessarily the best tool for this, but it is true. A lock would make a difference, right? But it doesn't have to be a Master Lock necessarily. But it's a ploy to kind of use that example to connect it to you. Okay. And the bigger the story, which is why people stretch the truth all the time, right? The bigger the fish, the more impressive the story, and the more likely it is to make an impression on you. So the stronger the example, the more powerful the example, the more likely it is to stick in your mind and be more truthful in your thinking. Okay. It's likely not more true at all, but you're likely to assume that it is because it had a more emotional impact on you, right? Some guys like, if you do this, you're going to do this, and it's going to fix all of these problems. Another person's like, you're going to die. Okay, that person's going to remain in your memory more than the guy who's talking all that. Okay. So group identity and the echo chamber of the like-minded. So groups and news that affirm our views are accepted. News sources that do not are demonized, right? You're a liberal, so therefore CNN is right no matter what, or MSNBC or whatever, and therefore it's right no matter what. Or you're a conservative, so therefore Fox News is right no matter what, when in reality it's probably all wrong. Or at least they just have small elements of the truth. But small elements of the truth is just enough to sell what they're selling, which is advertising, right? So anyway, that's a whole nother soapbox. So, but be aware of that, right? If people agree with you, you're going to listen to them. If people disagree with you, you're much less likely to listen to them, even if they're right. Okay. We're looking for people to confirm us because being confirmed in what you believe and what you think as reality is much more comfortable than being told you're wrong. So that's essentially where that struggle comes. Okay. And again, with today's world where we have so much social media and things where you can basically find these echo chambers, like super echo chambers, where you find everyone in your group is just thinking exactly the way you are, and it's pumping you full of videos like, hey, he's recommending this, and look at this, and hey, there's an advertisement. Okay. And it's all based around what they've seen your patterns to be it's going to get stronger and stronger and stronger, just reinforcing what you already think rather than actually giving you potentially what the truth really is. Doesn't matter which side you are, that's how it's going to work. Okay. For example, next slide, slide 4, psychological science in a post-truth world, part 2. These are, if you're looking at the pictures, you're gonna see like there's a cluster of red and a cluster of blue. So on social media, most people discuss contentious issues, right? Oh, if you've ever looked at Twitter at all or Facebook or whatever, like that's, yeah, okay. Gun control, same-sex marriage, climate change, all these things that are like, they're emotional hotspots for a lot of people. Typically, people who are on the left or people who are on the right, they're going to be sharing and communicating the information that's from their own bias, right? So, for an extreme example, if you're a flat earther, okay, if you're a flat earther, do some science. But if you're a flat earther, you're likely to be just sharing and being fed all these things that would agree with that idea that the world is in fact flat instead of global, or like instead of a globe, okay, instead of a ball, spherical. Okay, but anyway, if that's your thing, that's your group, you're gonna be basically looking for people who are gonna be supporting that thinking, and that's what you're gonna be pumping out there, right? Kind of an extreme example, but that's essentially what everyone does. This example here that we have with the two things is from a Twitter taken in 2017. They found that people in the blue shared liberal ideology. People with the red were conservative ideology. And what they found was that people basically, they sent messages that were from, and they were followed messages that were from their own way of thinking. Okay. There really wasn't that much intercrossing between the two groups, which is not healthy. Okay. If you really want to be a well-rounded thinker, you should be seeing these colors intermingled with each other completely, where the conversation's actually being carried on to see where does the truth actually lie, rather than like separating ourselves and just being totally isolated. Okay. Isolation does not lead to good thinking and good knowledge, typically. So anyway, slide 5. Scientific method, part 1. Again, psychology is a science, which psychologists support the scientific attitudes with the scientific method. We talked about the scientific attitudes in module 1. These are the steps of how you basically apply that critical thinking into an official pattern. Okay, so the key terms to learn are going to be theory. These are going to be some of the things you're going to want to learn for the little quiz over the chapter 2. Okay. So theory is an explanation using an integrated set of principles that organizes observations and predicts behaviors or events. Your theory is basically what you create, or it's the thing that gets you started. Okay. I have a theory that every time I eat cheese, I feel a sense of joy. Okay. I think cheese is causing me joy. So then you come up with a hypothesis. Okay. Hypothesis is a testable prediction often implied by a theory. So I think cheese is giving me joy. So this time I'm going to sit down and eat some cheese, and I'm going to see what my body does. Okay. And then operational definition is going to be a carefully worded statement of the exact procedures, operations used in a research study. This is important, especially if you're looking at research, actual research, right? Like if you go into an academic journal or the like, this is going to be important. And this is going to actually take up usually the majority of an article within an academic journal. It's going to be explaining exactly what they did. So my theory is that cheese makes me happy. My hypothesis is that if I sit down and eat some cheese, I'm going to be happier. Okay. My operational definition, I'm going to sit down with 4 ounces of Gouda cheese and sit and eat it and then observe my feelings and emotions for the following hour. Okay, something like that. Replication is repeating the essence of a research study, usually with different participants in different situations, to see whether the basic finding can be reproduced. And this is super important, right? I think in module 1 I talked about the red wine theory, or red wine study, where one doctor was like, this cures everything, and everyone was like, it sounds good, and then they couldn't replicate it. Replication, basically, if let's say 100 different groups do a very similar study. Okay, we're studying the effects of cheese on happiness, maybe, or we're studying the effects of caffeine on people with ADHD. Do people with ADHD, do they function better when they have a certain amount of caffeine, and just how much is it good, and how much is too little, too much? Okay, all those things. Or whatever the case may be. Okay, if we have 100 studies, and out of those 100 studies, 93 of them have almost the same results, we can assume, okay, that it is likely that the given theory, the given hypothesis, is accurate. Okay. Or if we have 100 studies and 93 of them come to realize that they can't replicate this, they can't get the same results that first study did, you can assume that something went wrong with that first study. Okay, the information was actually false, and there can be a lot of different reasons why that can happen. But that's where replication becomes so important. Okay. It's also why the operational definition is so important, because if you don't know exactly how I did my study or my research, you're going to have a difficult time replicating it, right? But if I can show you or tell you exactly what I did, you're going to have a much easier time basically doing the same study or something very similar to see if you can get the same results. Okay. Okay, meta-analysis, a statistical procedure for analyzing the results of multiple studies to reach an overall conclusion. So if you are a researcher, there's a couple different ways you can do this. One, you can actually be doing the operational definitions and the actual research, right, where you're looking and you're doing a given study. The other is you could be a meta-analysis, where essentially you take the research from a lot of other people. Okay, if 100 different people did it, you would take that information and you can compile it. And then from that compilation, you could then figure out what is the validity of the outcome of all of these studies. Okay, you're looking at the big picture, right? The meta-universe, the meta-analysis. You're looking at the big stuff. You're pulling in all the smaller things, the micro things, the individual studies, and you're comparing them to each other. If you like math and you like statistics, that might be your thing, because that's basically what you're doing. You're going to be crunching numbers from everyone else's research to figure out what is the reality of a given thing. A case study is a descriptive technique in which one individual or group is studied in depth in the hope of revealing universal principles. What we might consider like an experiment, often another way to look at this would be a case study. Okay, this is where you take like I said, if I was looking at the cheese bring me joy, okay, kind of a thing. I would be that case study. Eating that specific cheese would be my thing. Okay. So yeah, that's pretty much that. Naturalistic observation, a descriptive technique of observing and recording behavior in naturally occurring situations without trying to manipulate and control the situation. Anthropologists typically utilize this form. Okay. This would be me, or if I didn't look like a creeper, right? This would be me going and sitting in a park, watching a bunch of kids play, and then just writing down what I observed. Okay. This could be you at the mall, watching people walk around and just writing down what you're observing. You're not interacting with them. You're not messing with them. Not changing anything. You're just observing them in their natural habitat to some extent. Okay. In some cases, they do this in the lab, right? They might bring somebody in and they give them a certain situation, and then they just kind of step back and watch. And that's going to be that naturalistic observation. Okay. Surveys, we're going to go through these more in depth as we go throughout this scientific method thing. But surveys, a descriptive technique for obtaining the self-reported attitudes or behaviors of a particular group is usually by questioning a representative random sample of the group. Okay. We're going to go more in depth on that a little bit later. But essentially what it is I just ask you, what do you think about this? Okay. It's tricky to do well. It's easy to just ask people random questions, but it's difficult to do it well where you're actually getting true information from them. It's limited in its usefulness. It can be very useful, right? But basically what it does is it gives you a snapshot of this moment, what the majority of this group think, okay, where they land. And some groups there's companies that have gotten really, really good at doing this, and they can get really accurate information. But it is a skill in and of itself to do it well. So, okay, next slide. 6, the scientific method, part 2. Useful theories. Organize observations, right? You're observing all these different things and it kind of compiles them and organizes them in a way that actually makes it usable. It implies predictions that anyone can use to check the theory or to derive practical applications. Maybe my findings are that cheese, in fact, does bring you happiness. And so I say that if you can eat, if you're feeling a little bit down, eat 4 ounces of cheese and you're good to go. You can apply it to a given situation. Okay, if I'm studying the effects of caffeine on people who struggle with ADHD, I can then basically potentially apply that. Like I could say, if you consume, I don't know, 120 something milligrams of caffeine a day, if you have ADHD, this will reduce the kind of scattermindedness that oftentimes comes with ADHD. I use ADHD because I personally actually have ADHD, so that's it can be challenging. You might notice little rabbit trails every now and then with things like this. But anyway, they found that actually caffeine can help people. Another thing that can actually help people with ADHD is nicotine. There's a very high tendency for people who have ADHD to smoke. Trade-offs there is cancer or potentials of cancer, so there's pretty heavy trade-offs. But it can in fact calm the mind. Okay. So anyway, there's again research has shown that has been an effective tool potentially. Drawbacks are the side effects, but yeah. So where was I going with this? Imply predictions to anyone, and you can use it. You can then take that information. A certain amount of caffeine is good. Too much caffeine, again, if you have ADHD, depending on your level, how intense your ADHD is, different amounts of caffeine can affect you negatively or positively, right? A certain amount is good, kind of calms you, brings your mind into focus. Too much though, and suddenly you're jittery and off the charts. May stimulate further research that leads to a revised theory that better organizes and predicts observation. So my theory, if I give you a good solid theory, it allows the next people that look at my research to take that information and then try to replicate it, right? And maybe come up with something new. Maybe it's the next step. They're like, okay, if caffeine works, maybe this other substance would work that's similar to caffeine, and maybe it'd work with less side effects, or maybe it'd work more effectively. Okay, open up additional doors, right? Nicotine works, so maybe we can figure out a way to do this without increasing chances of cancer and heart attack and things like that. Okay, so okay. Next slide, slide 7. This is an image you also find in the book. This is the basically the process of how theory or scientific method works. So we have theories. The example: sleep boosts memory. Okay, that's a theory. If you get enough sleep, your memory is going to work better. Led to hypothesis, which is when sleep deprived, people remember less from the day before. Okay, if you're tired, you're not going to remember as much as if you were well rested. Which led to research and observations, which give study material. Example is give study material to people before A, an ample night's sleep, and B, a shortened night's sleep, and test memory. What they found was that in fact sleep does improve memory. If you are well rested, you will have significantly better memory than if you're not. So if you're a student, get enough sleep. Okay, that's basically that's. I know as a student, as a former student, as a person who just kept on going back to school, sleep, eating enough, getting some exercise, and drinking enough water, and then breathing well. We have it as humans, and especially looking at a screen like you are right now. We have a tendency to actually reduce our breathing, which reduces our oxygen levels, and it causes all kinds of problems. We'll look at that later when we look at different body parts. But get enough sleep is basically the moral of the story. Your mind will thank you for it, and your grades will actually generally improve as long as you're well rested. Okay, you can pull that information more at that point compared to people who aren't getting enough sleep. Okay, slide 8. Scientific method part 4. Description in psychology. Case studies suggest fruitful ideas for future research. No generalizations or universal truths. A specific case study, and a lot of people argue that this is in fact what Freud had, right? Which is why he kind of is debatable, to say the least. But a case study, it gives you like I might start with say 20 people or 50 people, okay? And I do an experiment with these 20 people, and I find that certain things are going to be true for them. And I try to reduce as many different factors outside of it and all these different things. But at the same time, it's not going to be an obvious truth at this point. It's going to be interesting or intriguing, and it might open up the doors to potential truth. But once you have like 100 studies or 1,000 studies in some cases that basically agree with each other, and there's very little issues with that, that's where you get closer to having an actual universal truth. Okay, something that in fact is the way it is in reality. Okay. Again, natural observation often involves new technology, movement to big data, right? We're natural observation, basically all of the social media has made this so much easier for research psychologists. I want to know anything about like the population as a whole. Twitter, Facebook, Instagram, Pinterest, all of these groups are basically just compiling people's lives and their reactions and observations to all these different situations. I can just pull right from that. And most of those companies are more than willing to work with researchers, and so that's something that they can utilize nowadays. It's crazy, right? Like it really is amazing what you can pull from these things. Doesn't control all the factors, right? Natural observation, basically, in a lot of times cases, you don't have any of the factors controlled, right? If I'm observing how people just act on Facebook, I'm not controlling them whatsoever. I am simply pulling their information. Describes and sometimes illuminates but does not explain behavior. So I can say, this is what I saw happening. Okay. Anthropologists in Papua New Guinea say, I observed them doing this ritual. Don't know why, don't have any background behind it. This is what I saw. Okay. Same thing if I was watching animals or things like that. Naturalistic observation is going to be typically what people are doing when they're doing like biology research on wild animals and things, right? You're sitting, you're observing the animal doing what they do in their given environment, and you're trying to keep yourself out of it as much as possible. All those documentaries you see, like the Planet Earth and all those kind of things, that's what they're essentially doing. It's naturalistic observation. They're observing the animal in its natural habitat, doing what the animal normally does without interruption. Same thing in psychology, which is with people. Okay. This is also something actually to keep in mind when you're thinking about popular psychology, pop psychology. A lot of this is kind of what they're utilizing. Okay. And you also need to understand, like, what is it in fact? What is the research that they're giving in the case study? And did the intention that they show in pop culture, like what the media is putting forward, is that what they actually found? Okay. That's a big one, right? Because a lot of times what the media puts forward isn't what the researchers were actually even looking for, and it's not what they actually found, but it sounds a lot better than what it is that they actually found. Okay. So yeah, so keep that one in mind. I'll explore that later on in the semester as we look at some different aspects of how we develop and things like that, but here we go. Do big data make naturalistic observations a big deal? The answer is yes, to some extent, and it makes it much more easy. Okay, so again, this is slide 9. This image is also found in the book on page 22. Assuming you have the same edition and everything as my book. But we're looking at essentially, it's a graph, and it shows how many people use positive wording in their tweets on Twitter at a given time on a given day. Okay. What they found was that the highest point of positive comments was very late Saturday night and very early Sunday morning of any given week. Okay. The lowest dip, the very, very lowest, was Tuesday afternoon. People get the most negative on Tuesday afternoons. Tuesday and Thursday, interestingly enough, are two of the more difficult days for most people. You made it through Monday, but you're just feeling kind of bleh, right? You're right in the middle of everything that you don't want to necessarily be doing. And so therefore that kind of puts you on the list. Why might this be important? Okay. Well, if you're an advertiser, this becomes extremely important. This is in fact where Twitter and Facebook and all these guys make their money, is through advertising. If I'm wanting to advertise to you, say like ways to up yourself, right? Improve your mood. And I know I'm looking for that point when you're at your down in the dumpsist. I'm going to pump those advertisements on Tuesday afternoon, okay, and have the highest chance of having some kind of impact upon you. On the other hand, if I'm trying to give you something that's like, you're like already up, right? You're super happy and life is good. I'm going to hit you Saturday night. There's a good chance that'll have the biggest impact on you. And so depending on what I'm trying to get to you, those can be different things that we can look at. And different methods, even for the same product, can be utilized in the advertising on those times, for example. Okay. Next slide, 10, scientific method, part 5. An ear for naturalistic observation. This is a little thing from page 23 on the Retrieve It. So psychologists Matthias Mahel and James Pennebaker have used electronically activated recorders, or EARs, ears, to sample naturally occurring slices of daily life. Okay, they just do a recording and they can hear it. Advantage, they hear people just talking about what they talk about. Disadvantage, they have no control over or understanding of why they're talking about that given thing within what they're actually observing in that moment. Okay. 11, the scientific method, part 6. Descriptions in psychology. Surveys and interviews ask people to self-report behavior or opinions of particular groups. Okay. Seems pretty straightforward, right? There are some significant differences though. So wording effects is going to be a big one, right? How do I word the questions, and in what order do I put the questions? I've seen people who are actually really good with, I've seen people who are really good with surveys can basically make you say anything. And it's amazing. But a really simple example of this would be, if I were to ask you, do you believe in aliens? Okay. A lot of people would say no. If I just put it that way, do you believe in aliens? Because when the word, well, I'll talk about that second. So anyway, if I say that, okay. If on the other hand I say, do you believe in life somewhere else besides this planet? Like, could there be life on another planet somewhere else in the universe? Okay. More people are more likely to say yes. Okay. Partially because when I use the word life on other planets, all of a sudden you're like, okay, I could picture like some like mushroom growing on Mars or something, you know, right? That it opens up the doors to a lot more possibilities of things that are just out there on another planet somewhere else. There could be a tree growing on, you know, some planet light years away from here. Okay. If I say aliens, we've been kind of programmed to picture, you know, little green men and flying saucers visiting this planet, and they're a little bit less likely to be like, I don't know. Okay, I don't think that's what I think. Okay. So wording can affect your overall outcome. It's the exact same question. An alien and a life form off this planet is the same thing. The images that it produces in your mind, though, are significantly different, which will then change or alter the outcome of this. When I asked this question in class with people present, right? I had a class with like 60 people, and I asked this question. When I asked about aliens, I had like 3 or 4 people like, yeah, okay. When I said, do you believe in life on other planets somewhere else in the universe, or extraterrestrial somewhere else on the other universe, I had closer to like half the class oftentimes would raise their hand. Okay. Big difference. Same question, slightly different wording. Okay. Sampling is going to be a big thing, right? Representative sample, random sample, and population are going to be all aspects of this. Random sample is just that sample that fairly represents a population because each member has an equal chance of inclusion. Okay. So that's essentially what you're looking for. A representative sample is going to be like, I'm going to take, this is what these companies do. They look at a given group and they take percentages, right? If there's a certain percentage of this kind of people in this thing, I'm going to make sure that my grouping has a certain percentage of those same kinds of people, right? So if I'm doing like a religious study or a religious survey, let's say, I'm going to look at a given city, look at what the percentages of the different religions are, and then draw from that many people, for example, as a possibility. Okay. Random sample is going to be, I'm not picking and choosing the specifics to try to get my answers the way I want them to be. I'm just picking randomly from those groups. And then the given population is going to be all those in a group being studied, from which samples may be drawn. Okay. So if we're doing like a survey of the United States, you know, you've got 380 some million people that you're drawing from. Any one of them technically could have been chosen randomly. Okay, that's going to be the populations you're working with in that case. If I'm looking at a specific city or a specific community, that will reduce the numbers, obviously. So best basis for generalizing is from a representative sample, okay, which we already talked about. Unrepresentative sample cannot be compensated for by simply adding more people. If I'm like, the United States says, okay, for example, I actually watched CNN a while back, and they had a thing that said, if you think this and this and this, you know, text in this your answer, yes or no, or whatever. Okay. A little while later, they were like, America says, 80% of Americans think that blah, 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 blah. Okay. And I basically burst out laughing because I was like, no, they don't. Okay. 80% of people who are watching this show at this moment with a cell phone that they're willing to actually take the time to text on, okay, that means they have the capability of texting all that, are doing this. Okay, that's what they think. This population is a very small population compared to the United States, right? And you can't just be like, well, more people who are watching this show currently are going to give us a better example. No, because it's this very specific population. Okay, I've seen similar things on Fox too. So it's not just like yeah. Anyway, news, it's almost not even worth watching. But anyway, whatever. Okay. But yeah, that's going to be that's what we're looking at. If I'm actually studying the United States, I need to be spreading my net wider than a specific show. Now, it would be very useful to maybe say that 80% of people who have cell phones and are watching the show think this. That could have been useful for them for like ratings and things, but they don't, not necessarily for an actual understanding of what the United States stands. Okay. Scientific method, part 7. Correlation, a measure of the extent to which two factors vary together. How well the factors predict each other. Okay. I said slide 12, right? Scientific method, part 7. Usually explains only part of the variation among individuals, and it uncovers naturally occurring relationships. Okay. For example, this is a legitimate correlation. Okay. As ice cream sales rise every year, violent crime also rises every year. Does ice cream sales cause violence? Does violence cause more people to go out and get ice cream? Okay. Those would be causation. Correlation means that these are two things that are actually not related directly, that happen to rise and fall at the same time every year. The real reason for this is actually the weather. Okay, as weather warms up, violent crime comes up, as well as ice cream sales. As the weather cools back down, you see them drop off. Okay, that's the weather is causing them, but they're two different factors that are equally measurable. So as you see ice cream sales rising, you can assume relatively accurately that violent crime will also be on the rise. Okay. If on the other hand it was a flip-flop, right? As ice cream sales went up, violent crime went down, they would still correlate with each other, and especially if they did it exactly the same, right? They're like back and forth. This would be a negative correlation though, in this case. Okay, so positive correlation is what they do when they're up and down together. Negative correlation is when they have the flip-flop. Okay. So that's the coefficient, the statistical index of the relationship between two things. Okay. And then some things will have no relationship whatsoever. If like ice cream sales go up and violent crime is just, and then ice cream sales go down, and for some reason violent crime goes up, and then ice cream sales go up again, and it stays up there, and then all of a sudden it drops. Okay, there's no connection. There's no correlation even to those things. So it's important to recognize that correlation does not equal causation. If it correlates, it doesn't necessarily mean it causes it, right? Cheese eating, for example, might not actually be the thing that brings me joy. Maybe something else happens that brings me joy. But it just so happens that there's a correlation between me eating cheese and me getting happy. Okay. I don't know why cheese is my thing today. Anyway, okay. 13. And so, part 2. Correlation does not prove causation. Correlation suggests a possible cause-effect relationship, but does not prove it. So, when you see like there's a correlation, in fact, ice cream sales could cause violent crime, or violent crime could cause ice cream sales. Okay, that there could be a causation there, but it doesn't necessarily mean that there is, which there isn't, is what we found. So remember this principle, and you will be wiser as you read and hear news of scientific studies. If you actually read the scientific studies, you're much less likely to see false connections of causation. On the other hand, if you just observe pop culture, right, all the popular stuff and what news and random things are giving you, you're much more likely to see correlation put forward as causation. Okay, so be aware of that, and you'll be much better off in the long run. Scientific method, part 8, slide 14. Experimentation. So experiments enable researchers to isolate the effects of one or more factors, right? Manipulates the factors of interest to determine its effect, holds constant, controls other factors. Okay. So if I'm looking at caffeine, okay, I'm gonna give one group say a dose of, a certain dose of caffeine. I'm going to give them a cup of coffee, okay, approximately 128 milligrams of caffeine in it or whatever. I'm going to give another group a cup of decaf, and I'm going to give another group a glass of water. I'm going to observe and see what happens. So the experimental group receives the treatment. The experimental group is going to be the group that actually gets the caffeinated coffee to see what the effect is. The control group does not receive the treatment. That's going to be the group that gets the decaf coffee, and in this case also the group that gets the water. Both of them are a control group. Okay. You take a random sampling, creates a representative survey sample. In this case, okay, your different groups, and a random assignment equalizes the experimental and control group. So I'm going to take, if I have 100 people, right, or 99 people, you have 33 people randomly chosen from this 100 or 99, and put them in one group, 33 in the other group, 33 in the other group. Okay. So yeah, and essentially I'm going to be observing, are there differences? I'm going to have maybe a series of tests or something afterwards to see how the caffeine affects them. Does it, cause more irritation? Does it make them more likely to actually understand what they're looking at? Are they comprehending things quicker, slower? All these factors. Okay. They did an interesting experiment actually quite a while back now, probably 10, 15 years ago, to see what the effects of alcohol were. And they took a group of people and they gave them water. They took a group of people and gave them alcohol in a significant amount, enough to get you drunk. And they took another group of people who had a drink that tasted like alcohol. It had the same burn and everything of alcohol without the intoxicating effects. In other words, it will not make you drunk no matter how much you drink it. What they found were the people who thought they were drinking alcohol but were not acted the most drunk out of the three groups. And so they discovered that alcohol, in fact, is also a mental game, right? Somebody who expects to be drunk gets drunk. Somebody who doesn't expect to get drunk, they're still going to get intoxicated, right? Their brain is going to still slow down because of the physical changes. But if they have no expectations, it's going to affect them differently than somebody who thinks that they know what's going to happen. Okay. Yeah. Weird stuff. You could actually have more fun thinking you're getting drunk than you would actually getting drunk. So, slide 15. Scientific method, part 9. Procedures of the placebo effect, and that's actually exactly what that was. Okay, the double-blind procedure. So it's an experimental procedure in which both the research participants and the research staff are ignorant or blind about whether the research participants have received the treatment or a placebo. In this case, that fake alcohol was a placebo, right? They thought they were getting something, but they weren't. If I'm doing good research, I'm going to set it up where one person maybe knows who's got what. Okay, but I, the researcher, don't know which group got which. Whether that be medicine, whether that be trying to figure out the effects of something on you in long term, short term. I'm not going to have a clue of which is doing what. All right, I'm back. So placebo effect. So the experimental results you cause by expectations alone, right? If I think so, this is actually this can be used in the medical field a lot actually. There's certain medicines that are in fact not medicines. They give you basically a sugar pill. Okay. It seems like medicine. Your brain says it's medicine. You take it, and in some cases it cures you because your brain thinks you're taking medicine, and you actually have an amazing amount of power over your body with your mind. And the placebo can in fact cure you to some extent. In fact, what you've done is you've just cured yourself. But the placebo makes it feel like you've done something, right? A lot of times doctors will actually use this if they're not sure what's wrong. They can prescribe a sugar pill and see what happens, right? If the person gets better, then awesome, they're better. If they don't, if they just they remain the same, or if they get worse, then they know that that's not the case, and they can kind of work with it. So, yeah, that's a big factor there. 16, scientific method, part 10. Getting close to done. Variables. The independent variable is an experiment. In an experiment is manipulated. Its effects is being studied. Right. We're going to talk about this a little bit. So, confounding variable is a factor that might influence a study's results. Let's say I'm trying to study caffeine, but it actually turns out it's just the flavor of coffee that's having an effect or something like that. Okay. So the dependent variable is the outcome that is measured. It may change when the independent variable is manipulated. So you have your experimental group and your control group, and you have the image here. See, I think it's on the book. I'm just making sure. Yes, on page 28. You can find this image that they have here. You have the experimental group. They did a study on breast milk and the effects of breast milk versus formula. They found that breast milk, children who were breastfed, uh, they had higher scores of intelligence by age 8 compared to children who were only formula fed. Okay. So is that the breast milk? Is that the breastfeeding? Like what aspect of this made that difference? We don't know exactly. Okay. Quick note on that one too. If you're a mother and you can't breastfeed for some reason, don't feel bad. Okay, the numbers were actually extremely close. It was just a minor difference in the two. Statistically, it really wasn't even that significant of a difference, but it was enough to be, you could kind of take note of it. But different people have different issues. Like breast or formula is an amazing thing for mothers who can't, because that can happen. There's all kinds of biological things and things that can make that an issue. So just be aware of that. When we look at like human growth and development, breastfeeding and things like that, there really are some significant benefits, but it's not the only way to go, and it's not going to ruin your life if you don't have it. So, okay. I've seen some people get shamed for not being able to breastfeed. I'm like, that's terrible. Like, don't do what you can to take care of your child, basically. So, okay. 17, scientific method, part 11. How would you know which research design to use? So developing a testable question is going to be your first thing, right? Maybe I'm looking at the happiness of cheese that cheese makes, or the effects of caffeine, or the effects of alcohol, or whatever. Okay, come up with a question on it. Select the most appropriate research design from there. So you look, depending on what it is you're trying to find, are you going to create an experiment? Are you going to look for like correlation or causation? Are you going to create a case study? Okay. You're going to find these. There's a table on page 29 and that kind of gives you some breakdown of this for comparing research methods and the like. Natural observation can be really useful. Twin studies are kind of fascinating ones. Twin studies are basically where you take identical twins that are genetically the same and you can put them into a study. We'll look at them a little later on. And we definitely, if you take Psych 235, this is something that comes up a lot in the human growth and development classes. But you take identical twins who are genetically identical, right? If I took DNA from twin A and I took DNA from twin B, you couldn't tell the difference. They're exactly the same, basically. I could put them in different situations and see what happens. Okay, that way I could see how much of an effect the environment has upon them, rather than just their genetic behavior. Longitudinal studies. Am I taking a group of people and I'm studying them over the course of a lifetime or a course of a year? Okay. Seeing if there's a difference long-term, cross-sectional, okay, all these kinds of things are going to be potential tools for you in this case. Okay. You can find all these, again, more detailed versions of these within the reading. Measure the behavior or mental processes being studied. Okay, that's going to be another tool. And then interpret the results. Once you've figured out which study to use and you've done your research, it is then the researcher's job to basically interpret what it is they found. If they do a good job, it makes logical sense. If they do a bad job, which I've seen some terrible things in some very fast, like there's some very high-end academic journals, and there's some research, I'm like, my goodness, how did this get in here? But their conclusion, their interpretation is just like, man, that doesn't even seem like it shows from the material you gave us. But anyway, that's something to keep in mind. That's part of the process that the researcher should follow. Okay. Slide 18, scientific method, part 12, predicting everyday behaviors. So experiments test theoretical principles, right? They can be more or less useful in the like day-to-day kind of stuff. It's basically just saying this is what I think could be the case, right? It might in fact be the case, like with cheese, that in fact makes you sad. Okay, most people it doesn't. In fact, research has shown that cheese actually triggers the same parts of the brain that cocaine triggers. So it in fact does typically make you a little happier. Not as intensely as cocaine, but it's the same kind of reward centers in the brain fire up. Resulting principles, rather than any specific findings, help explain everyday behaviors. So what we're looking for, like the specific findings, give me the base to then make universal predictions. Okay. The more research has been done, the bigger the chances that that universal prediction is actually accurate. Again, this is where Freud kind of fudged it. He only had a handful of people basically he was working from. So his universal predictions were for a very specific group of people in a very specific class. Uh, they were relatively accurate given that group. When you applied it to mankind as a whole, not as accurate. Okay. But it gives you that groundwork to work with. So psychological science focuses less on interpreting specific behaviors than on revealing general principles that help explain many behaviors, right? I could say most people are going to react this way. One thing you're going to find with psychology too, there's two things you're going to hear a lot. One is we don't really know why, because it's still a relatively young science. So we have a lot of information. We know this happens. We don't know why. That's one thing you're going to hear a lot. The other thing that you're going to hear a lot is most people, right? Because not everyone is going to react exactly the same way. But you could say, 9 times out of 10, this is going to be the reaction to this given thing, right? And that's what you're looking for. You're looking for that statistically, the majority of people are this is going to be what we find to be the case. Okay. If you ever hear me use the term like everyone, which I don't usually use in psychology, but if you ever hear me use that for some reason, you can just consider that as I'm meaning the majority of people are going to go this way, right? It'd be like saying everyone loves football. Okay, well, not really, but a lot of people do. Okay, that's kind of the thing there. It's hyperbole, but anyway. 19. Psychology's Research Ethics, Part 1. So in Module 1, we talked about a couple different things like the conditioning the baby to be afraid of mice, things like that. Those are extremely unethical. Okay. In the last 75 years, give or take, they've begun to put into place a lot of different rules to try to help keep those kinds of things from happening. Okay, we don't want to be hurting people or causing damage on people that's not necessary. Okay, so the ethics are going to be things like protecting animal research participants. Right, animals don't have a voice necessarily, so it's up to us to basically figure out what's ethically correct for them. Animals can be extremely useful in research. So to understand species differences and similarities and to investigate treatment for human diseases, for example, those are some different ways that they can be very useful. Psychological, biological, and medical research is also going to be using them significantly, right? Partially because they're simpler. Okay. If I want to understand conditioning and I can figure out how to condition a fruit fly, for example, to do a specific thing, those basic principles at that simple level can be expanded upon to the more complex creatures. So I can look at how humans are conditioned and things like that. Okay. So those are going to be factors there. Goldfish are another one. You can actually condition goldfish to do things. Basically, you can train them to do certain things through conditioning. So key issues to protecting animals. Is it right to place the well-being of humans above that of other animals? And that's going to be a ethical debate basically to this day. Okay. So in other words, could I intentionally cause harm to an animal if it'll bring about a greater good for humanity? Okay, that's the question basically. And which safeguards should protect animal well-being in research? Okay, there's a few different guidelines. You're gonna have the British Psychological Society, or the BPS, that has certain sets of rules for if you're in Britain. The American Psychological Association, or APA, guidelines are going to have a different set. They're usually pretty close, but there are some differences. European Parliament standards, University Ethics Committee guidelines. Okay, these are all things that are going to be put into place. They're going to have a certain level of. It gives you the boundaries of how far you're allowed to go. Okay. Sometimes when the places that are wanting to cross those boundaries, you're like, why? But anyway, the tendency is. It's like, okay, you can go this far, but you can't go that far, right? That becomes unethical and dangerous, and you're just causing harm for harm's sake. Same kind of thing lies in the medical field. Different organizations, but similar kinds of guidelines. Okay. 20. Psychology's Research Ethics, Part 2. Protecting human research participants. So ethics code of the APA and Britain's BPS. You have to obtain potential participants' informed consent to take part. I can't just do research on you randomly, okay? I can't force you to come into a lab and do research and study you. So I have to get your permission. And I can't just randomly slip something into your food or something and then see what happens, right? 1970s that actually happened, or 1960s that happened in the military a lot. They'd have like a platoon and they'd be like, oh, okay, here's your lunch. And then, but there'd be something like LSD or something slipped into it. And then they would be like, oh, weird. They had lots of negative effects. Go figure. Okay. So yeah, they're not allowed to do that anymore. Okay. Protect participants from greater than usual harm and discomfort. Okay, sometimes some of these studies can be very uncomfortable, right? You've probably seen like a lot of different TV shows like Mythbusters and things. They'll do those like pain tolerance where you put your arm in a bucket of ice or something. It's uncomfortable, right? But it doesn't cause long-term damage necessarily. I guess it potentially could, but generally it doesn't. And that so the percentages of chances of long-term negative issues are relatively low. Discomfort is going to be a fact. Overall, damage relatively low. Okay. Keep information about individual participants confidential. If you look at this research, they're not going to say, well, Joe Schmo, this is what his results were, and Susie Palucki down the road or whatever. They're not going to do that. Don't know where those names came from. But anyway, the tendency, they'll just say, these are the numbers, right? Out of the 100 participants, 58 of them did this, okay, or whatever. And a lot of times you can't even find out who those people were who were in the research group. They fully debrief people. So once the research is done, they explain the research afterward, including any temporary deceptions. In some cases, they're going to intentionally tell a lie, right? They might bring somebody in and say, we're researching, I don't know, we're researching the effects of this substance on people. And the person's like, sure, I'll do that. When in reality, what they're observing is like people waiting in the waiting room or something like that. Okay. And then they have to, so that's going to be the ethics codes. And then they have to follow university ethics guidelines, which are going to be guided by the given universities to give them those additional limitations above and beyond what you'll find in the Code of APA and Britain's BPS. Okay. Almost last slide, 21. Got 2 more slides of this one. Psychology's research ethics part 3. So research values influence topic choices, color the facts of observations and interpretations, and may be hidden or unconscious. So this is understanding who the researcher is and kind of where they are coming from is going to have an impact on what they end up finding to some extent. Okay. Most people aren't going to intentionally do this. They're not going to be like, I'm going to skew these numbers to make sure that they tell me exactly what I want to see. But they might as well to some extent because that oftentimes is what happens. Okay. So you got to look at you got to kind of understand a little bit of where the person's coming from, right? What's their reasoning behind what they've intended or chosen to answer for. So again, this can be something that the person's not even aware of. The researcher might not be aware of the fact that they have this personal value that is in fact influencing their overall results. And in some cases they're aware of it, but they don't want anybody else to be aware of it. So they're going to kind of keep it under, low key kind of a thing. So things to be aware of when you're observing research and how it's working. 22, use psychology to become a stronger person. So this is where you can actually apply what we just learned to yourself. Evidence-based suggestions for living a flourishing life. All right, you're going to find this in the book also. But getting a full night's sleep, like I said, sleep, exercise, eating and drinking enough and eating the right stuff, right? You're not going to just fill yourself with Cheeto Puffs and Mountain Dew or whatever it is, Rock Stars or whatever. Eating healthy and then breathing well. If you have enough oxygen in your system, you're going to have a much better experience overall. So sleep, exercise, set long-term goals with daily aims, right? Long-term goal, for example, long-term goal, graduated from PCC, you're here in this class, right? Daily goals, you're going to, depending on which semester you're in, you're going to look at how much you need to get done per day in order to make sure that you get or achieve that long-term goal. Okay. You also might have a plan on kind of what classes to take which semester and all those kinds of factors. Okay. Have a growth mindset. Growth mindset is the difference between somebody who says, I can't, and I can't yet. That little word yet makes a very big difference, right? I asked somebody can you do this math problem? They're like, I can't. I just can't do it. I hate math. I just can't do it. Okay. Versus somebody who says, I can't yet. right? I haven't learned how to do it yet, but I understand that if I apply myself, I eventually could. That's important. That's something we can learn early on as a child. If you haven't learned to do that, you can intentionally do that. Basically, again, just by adding that word yet, right? As soon as you find yourself saying, I can't do this yet, throw that yet in there, and it actually will change how you perceive the given task. Okay. And then prioritize relationships. That's one thing they found with happiness, is that relationships are going to be key to having an overall well-balanced life. People who have more friends and or family that they feel connected to are going to experience life at a much higher level and are going to flourish basically at a higher level. Okay. Now that doesn't mean that you like, well, it's Saturday night, and so, I should be doing this, but oh well, I need to prioritize relationships. Okay, that's not necessarily what it means, but at the same time, make sure you're taking time to be with those that care about you and that you care about. Okay. Slide 23, use psychology to become a stronger person, part 2. Evidence-based suggestions for learning and retaining information. Practice self-testing and rehearsal. So the testing effect, the tests in this class that you're actually going to be taking are relatively low. And I just realized I have not given any of the things. So we're going to go ahead and do those real quick. Okay. Number 1, the line in Titanic, I'm king of the world, was improvised. Okay. Titanic is where that one's from. We're going to do another one. Iceland has no railway system. Weird. Okay. It kind of makes sense when you actually look at Iceland, but yeah, there's no railway system. We're going to go through one of these and then we're going to go back. SQ3R, study method, survey, question. Actually, I'm going to go back. Practice self-testing and rehearsal. Okay. The more you test yourself, like I said, the tests in this class aren't going to be super strong. What I found is that the testing, honestly, it gives me an idea of what you know at this moment. It doesn't actually show me what you truly know. I've had people who could fly through tests and they were amazing at them when I had a really complex test, and I would ask them a question outside of the test, they'd have no clue what I was talking about. I had other people who would bomb the tests because they're just terrible at taking tests. But if I talked to them about the material, they could answer all kinds of questions. And they could go in depth on it and everything else. So it didn't really show me much of what they know. That's why I've basically developed these tests to be a test to make sure that you're reading the work and listening to these lectures. But testing, okay, utilizing testing as a student where you're testing yourself, you're going through maybe looking at the questions at the end of the modules or things like that, testing yourself, it can greatly improve your retention of that information. It'll also show you where you're weak within the given topic. Okay. With this also, a good way to test yourself is actually to basically teach it to somebody else, or whether that be a person, a cat, a dog, a pillow, whatever. But just teaching it to someone will show you where your weaknesses are again in a given area. Okay, next thing. Number 3. Elvis was actually blonde, but dyed his hair black to look edgier, sometimes using shoe polish to touch his own hair up. Ugh. Okay, anyway, blonde guy. Want to be black haired though, because blonde seemed wimpy to him, I guess. So yeah, practice self-testing. SQ3R, you're going to find more information on that in the book. There's also a ton of information if you go to YouTube and things and type in SQ3R study method. You're going to find a lot of information out there. That's basically survey, question, read, retrieve, review. Okay, so when you're going through your information, it's actually a good way to read a textbook. You survey it, you just kind of run through it. Like let's say you're studying module 2, right? You run through the module real quick, look at the headlines, look at the little side margin notes and things like that. Take a quick survey. Jot down some questions you have about that, given the information you have from that little bit of a skim. Okay. Read it. So you go through and actually read it more in depth. And then figure out, like, were you able to answer your questions from it and things like that. Retrieve it. In other words, come up with a quiz and try to test yourself on it, and then review it. And reviewing it doesn't mean going back and rereading the entire chapter. Reviewing it means you're going through and picking up those key notes, right? You could basically go back through and survey again, look at the highlights, and then see how much information you can just give about that given thing. So like here, you're like, use psychology to become a stronger person and a better student. What are these things that you're learning right now? Okay. Final bit on the quiz. German chocolate cake was named after American baker Samuel German. It has nothing to do with Germany. It has to do with a dude named German who made a really good chocolate cake. Okay, some additional study tips. Distribute study time. Learn to think critically. So that's another thing. Distributing your study time. If you sit down for like 5 hours straight, you're not going to retain as much as if you sit down for like 15 minutes or 30 minutes in a given stretch. Generally takes a little bit of time to kind of get in the rhythm. So give yourself more than like 4 minutes or 5 minutes. You need like 10, 15 minutes at least. But break it up throughout the day. Also, if you're studying for tests, it's better to spread that time over several days, right? Like a week before the test comes, you start studying, you study like maybe total of an hour a day or something, compared to studying like 7 hours all at once in one day right before the test. Okay. You will not retain that information very well. If you spread it out, it will become part of your thinking. So distribute your study time. Learn to think critically. We talked about that in Module 1. Like learning to ask questions and really like, basically approach life and learning as a scientist would, like really processing that information as much as possible. Process class information actively, right? Taking notes. What they found is if you take notes by hand rather than typing them, you'll actually retain more information to some extent because the physical action seems to cause a greater retention rather than just the typing of fingers. Okay, you can get more information down on the paper generally typing. Writing it though will make it stick in your head a little bit more. Okay, that's what research has shown at this point. We don't know why. Again, that's one of the things you're gonna hear. But yeah, those are gonna be your things. Okay, and then finally, overlearn. I've learned this as a teacher. For me to teach a 1 hour class, I need about 8 hours worth of information in my head. Okay. And so you need to learn more than is required of you if you really truly want to master a given subject. So if you're going for psychology, you should be going above and beyond what's in the book and what these lectures are teaching you, right? You're looking for, other videos, you're looking for articles, you're looking at research, and you're pulling all that together to truly master the given product. If you're a biology student, that's the same kind of thing, but in biology. Mathematics, history, physics, whatever, okay, automotive, welding, whatever, go above and beyond what is expected of you, and you will truly achieve mastery of a given task. Okay. There's the 4 questions right there at the end. As always, if you have any questions or comments, send me an email, send me a message in the D2L or in the comments. Again, in D2L. So the discussion board, kind of thing. There's a question section in there, so let me know. And good luck with everything. I will see you all later. Have a good one.